In today's digital landscape, downtime is unacceptable. Imagine your website crashing during a major sale. Customers are frustrated, sales plummet. This is where load balancers become critical. They distribute network traffic, ensuring applications stay online even during heavy demand. F5, a leader in application delivery, offers two powerful load balancing solutions: Local Traffic Manager, LTM, and Global Traffic Manager, GTM. F5's LTM operates at Layer 4 and Layer 7 of the OSI model. It acts as a reverse proxy, shielding servers from direct client requests. LTM excels in local traffic distribution within a data center. It uses algorithms to intelligently route traffic to the most available server. This ensures optimal application performance and prevents overload on individual servers. LTM also provides essential security features like SSL offloading and web application firewall capabilities. While LTM focuses on local traffic, F5 GTM takes a global approach. It operates at the DNS level, directing users to the best-performing data center based on factors like location, server load, and network health. This is crucial for geographically dispersed applications and disaster recovery scenarios. Imagine a data center outage. GTM automatically redirects traffic to a healthy data center, ensuring uninterrupted service for users worldwide. Both LTM and GTM are powerful load balancers, but their strengths lie in different areas. LTM is ideal for optimizing application performance within a single data center. It offers granular control over traffic distribution and security. GTM, on the other hand, shines in global load balancing, disaster recovery, and DNS management. The choice between LTM and GTM depends on the specific needs and architecture of your application infrastructure. SSL TLS certificates are essential for secure communication. They ensure that data transmitted between servers and clients is encrypted and secure from eavesdropping or tampering. F5 makes certificate management straightforward, providing a user-friendly interface and robust tools. Here's a comprehensive step-by-step guide to adding or creating certificates in your F5 environment, ensuring your network remains secure and compliant with industry standards. Step 1. Access the F5 configuration utility. This utility is the central hub for managing all aspects of your F5 device, including SSL TLS certificates. Log into the F5's web-based configuration utility. Use your administrator credentials to gain access. If you don't have these credentials, you may need to contact your network administrator. You will usually access this through a web browser using the F5 device's IP address. Enter the IP address into the browser's address bar and hit Enter. This will bring up the login screen for the F5 configuration utility. Step 2. Navigate to the SSL Certificate Manager. This is where you will manage all your SSL TLS certificates, including adding new ones and renewing or deleting existing ones. Within the F5 configuration, locate the section related to SSL certificates. This section is crucial for managing the security of your network communications. This might be under a section named Local Traffic, Security, or something similar. The exact location can vary depending on the version of the F5 software you are using, but it is typically found under one of these main categories. Once you find the SSL Certificate Manager, you can proceed with adding or creating new certificates, ensuring your network remains secure and up to date. Step 3. Generate a new certificate signing request, CSR. If you are obtaining a certificate from a certificate authority, CA, you will need to generate a CSR. Step 4. Complete the CSR information. Fill out the required fields in the CSR form. This typically includes details like your organization's name, domain name, geographic location, and email address. Ensure accuracy, as errors here can lead to certificate issuance delays or rejections. Step 5. Submit your CSR to a certificate authority. Once the certificate signing request, or CSR, is generated, the next crucial step is to submit it to your chosen certificate authority. This could be a well-known CA like Let's Encrypt, Sectigo, or DigiCert. Each of these authorities has its own submission process, but generally you will need to log into their website, navigate to the CSR submission section, and upload your CSR file. This process ensures that your request is securely transmitted and queued for verification. The certificate authority will then verify your request. This verification process can vary in length depending on the type of certificate you are requesting and the CA's policies. For instance, a domain validation DV certificate might be issued within minutes, while an extended validation EV certificate could take several days. Upon successful verification, the CA will issue your SSL TLS certificate. This certificate is a digital file that you will need to download and store securely. Step 6. Import the issued certificate. After receiving your SSL TLS certificate from the certificate authority, the next step is to import it into your F5 load balancer. This process involves logging into your F5 load balancer's management interface. Once logged in, navigate to the SSL certificate management section. Here you will find options to manage your certificates, including importing new ones. Look for an import or upload option within your F5's SSL certificate management section. Click on this option and you will be prompted to upload the certificate file you received from the CA. Follow the on-screen instructions to complete the import process. Once imported, your SSL TLS certificate will be active and your F5 load balancer will be able to use it to secure communications. Step 7. Install the certificate on the relevant virtual server. This step is crucial as it ensures that the virtual server can securely handle incoming and outgoing traffic. Without the certificate, the server cannot establish a secure connection, which is vital for protecting sensitive data. With the certificate imported, you need to associate it with the appropriate virtual server on your F5 load balancer. This association links the certificate to the server, enabling encrypted communication. Make sure to select the correct virtual server to avoid any misconfigurations that could lead to security vulnerabilities. This ensures that the certificate is used for securing traffic flowing through that specific virtual server. Step 8. Verify installation. Verification is a critical step to confirm that the certificate is properly installed and active. This step helps in identifying any issues that might have occurred during the installation process. It's crucial to verify that the certificate is correctly installed and functioning. A properly installed certificate will ensure that all data transmitted between the server and clients is encrypted and secure. This not only protects sensitive information, but also builds trust with users accessing your services. Utilize online SSL checkers or browser tools to confirm that the website served through your F5 load balancer is using the newly installed certificate. These tools can provide detailed information about the certificate, including its validity period, issuer, and any potential issues. Regularly checking the certificate status helps in maintaining a secure and reliable server environment. Step 9. Address potential issues. If you encounter problems during or after installation, double-check the steps above. Ensure the certificate file is in the correct format, the private key matches, and the certificate chain is complete. F5's documentation and support resources can be invaluable for troubleshooting. Mastering F5 load balancers is essential for IT professionals managing modern networks and applications. LTM and GTM offer robust solutions for local and global traffic management, ensuring application availability, performance, and security. Understanding their differences allows you to choose the right tool for your needs. By effectively using F5 load balancers, organizations can enhance user experience, improve resource utilization, and strengthen their security posture.